Today I'm going to show you a way of finding highest common factors. Now, if the numbers are small, then you can find highest common factors by just kind of staring at it. So, for example, if I say, what's the highest common factor of 18 and 12, then you can probably just stare at it and go, well, 6 definitely goes into both of them. Does anything bigger go into it? Well, the only bigger thing that goes into that is 12, and 12 doesn't go into 18, so we can kind of stare at it and say that's 6. If the numbers are a little bit bigger, then it starts getting a bit harder. So, for example, if I say, what's the highest common factor of 48 and 21, then you might not be able to get that quite so easily. Now, one thing that you can do is you can find all the prime factors of this and all the prime factors of this and then see which ones they have in common. So we haven't really talked about prime factors yet, but you probably know that you can factorize this number into primes and this number into primes. So this one's a bit easier. This one is clearly 3 times 7, and 3 and 7 are both prime numbers. This one, well, 2 goes into it, doesn't it? So you take 2, and that's going to leave you with 24, isn't it? So we can get another 2, and so that's going to leave you with, so we got 24, and now we're down to 12. So we can take another 2, and that will take us down to 6, and so we can take another 2, and that will take us down to 3, and then we've got 3. So if you look at this, this is 2, 4, 8, 16, and then that's 48. So if you look at this, you see that the only factors they have in common are this 3 and this 3. So the highest common factor of those is going to be 3. Now that's all very well, but when the numbers get bigger, this method gets harder and harder and harder. Because if I say to you 2, 6, 4, 1, 3, 8, 9, 9, 7, how are you going to factorize that into primes? It's quite hard, and in fact, factorizing numbers into primes is genuinely really hard, and a lot of cryptography and codes and internet security and everything is based on the very fact that it's very difficult to factorize numbers at all. So I'm going to show you a method that doesn't require you to factorize things into primes. So for example, let's look at 48 and 21 again, and let's do it a bit differently. So I'm just going to show you this, and then perhaps as if by magic, out will pop the highest common factor. So we start with 48 and we say, okay, how many times does 21 go into 48? How many times does 21 go into 48? Well, 2 times 21 is 42, and it's not going to go any more times than that, is it? So it's 2 times 21, and then what's left? Let's put a remainder over here. 2 times 21 is 42, so the remainder is 6, okay? So that just is true. So now I'm going to take this number and do it again. So 21, how many times does 6 go into 21? Well, 3 6s are 18, so it goes 3 times, and then what's left over is 3. Okay, so now I'm going to do it again, and take these two numbers, and I'm going to say, how many times does 3 go into 6? Oh, that goes perfectly. And the conclusion that I draw from this is that this number here at the end is the highest common factor of 48 and 21. So this is the highest common factor of 48 and 21. Wow! Why did that work? And will it always work? Let's try it again. Now I wish I'd written that a little bit further over that way so that I could fit another one in here. But let's try and fit another one in here anyway. Let's try doing 906. Okay, let's try and work out the highest common factor of 906 and 210. So this is now much bigger numbers. It will be much more difficult to do. So let's just do exactly the same thing as we did here. First, we say how many times does 210 go into 906? Well, I mean, 4 times, we know that 4 times 200 is 800, so 4 times 210 is 840. So 906 equals 4 times 210, so that gives us 840, and then how much is left over? Well, that's going to be 66 left over. Okay, so now I'm going to do it again, but now I'm going to do it on these two numbers. So 210 is, how many times does 66 go into 210? Well, 3 6s are 18, right? So 3 times 60 is 180. And so 3 times 66 is 180 plus 18, which is 198. Did I do that right? So 3 times 66 is 198. So how much is left over? Looks like it's going to be 12. Okay, let's do it again, this time on these two numbers. How many times does 12 go into 66? Well, phew, this is getting a bit easier now, because 5 times 12 is 60, and then there's 6 left over. Woo! So finally, I'm going to do it on these two numbers, and you can see we've finished now, because 12 equals 2 times 6. And that's the point. There's no remainder here, and that's the point where I declare we're going to stop and say this is the highest common factor. So the answer to that one was 6. Now, should we try and check this by prime factorization? What happens if we actually try and factorize 906 and 210? Well, 906, we can certainly take 2, right? So that will give us 453. Right? We can now do another 3 out of that, because if you add up these digits, remember, we're going to get 9 and 3, which is definitely divisible by 3. So this thing is divisible by 3. If we divide it by 3, we get 151. So we have 2 times 3 times 151. And now we can say to ourselves, is 151 prime? Well, how can we tell? There really isn't there aren't that many ways of telling, apart from by just trying to divide it by lots of different things. So, I mean, it's not divisible by 2, it's not divisible by 3, it's not divisible by 5, it's not divisible by 7, it's not divisible by 11, it's not divisible by 13, it's not divisible by 17, I don't think it's divisible by 19. I'm putting myself on the line here because I haven't got a calculator. Well, let's try doing 210, shall we? 210 is much easier to do, I hope, because it looks like 3 times 7 times 10. So this is 3 times 7 times 10, and 10 is 2 times 5. So now we can check, because if we had any higher common factor in here, it would have to have a 2, right, we know we've got a 2 in both of them, and we've got a 3 in both of them, and so the question is, have we got any more common factors? Well, we've already checked that 7 doesn't go into there, and that 5 doesn't go into there, so whether or not we've broken that down enough, we know that we can't get any more common factors out of it than 2 times 3, so that really is correct. Woo! The highest common factor of those two really is 6. So this method worked on both of these two cases. So do you think it's going to work in general? And the answer is yes, it's going to work in general. But why? Why is it going to work in general? We'll talk about that next time.